Method number 1, graph quadrilateral ABCD, and we'll talk. All right, let's move on. It's asking to prove just a trapezoid. Just a trapezoid. Not isosceles, that's coming up. Just a trapezoid. And you guys remember, excuse me, our discussion from yesterday? Trapezoid doesn't have it much. One property, right? One property. One pair of opposite sides parallel. So that's what we're going to have to do on ABCD here. And it's always nice to graph it because you can tell what the parallel sides are going to be. So I need your help proving AB and DC are parallel. It's a trapezoid. That's it. All right, so if I'm going to prove it parallel, let's talk about our discussion from this unit. What formula am I going to need to show they're parallel? What formula am I going to need here to show those are parallel, Jonathan? Two lines are going to be parallel. They have the same slope. All right, so here we go. I need the slope formula, everyone. Slope, right? We've been using rise over run. Okay, so step 1. Hey, let's go M for slope of AB, and then do the slope of DC. So again, give you guys a minute or two here to do your rise over run with AB and DC. All right, let's start with AB. Up and over, how many? What'd you get for your slope of AB? AB, Simon? 1/2. A lot of you probably did 3/6, but you remember this whole unit, I've asked you, please reduce if possible. And you'll see why once I ask somebody for DC, I want you to reduce. 1/2. And then how about the slope of DC? DC, Jared?
5/10.
Yep, 5/10, and this is the exact reason why I have you guys reduce. You just look at 3/6 and 5/10, you're like, they're not the same, but actually they are. They're both 1/2. Good? All right, step 2, tell me what you learned. What did we just learn about AB? It's not a trapezoid yet. Just tell me what you learned about the formulas up above. AB and DC, what did we learn about those two? 2, Bailey? They are?
Same.
They're congruent? You sure you want to say congruent?
They have the same slope.
That doesn't make them congruent. What are we trying to do here?
I don't know. Honestly.
All right, let's back up. I'm using the slope formula to show opposite sides are
they're parallel.
Parallel, right? Congruent would be congruent would be the distance formula. I got it. So AB parallel to DC. Because, all right, somebody else now. Tell me how I know they're parallel. Why are they parallel? Lily? That's all because slopes are equal or congruent. Yep. And that's it. right? Hey, I don't need to touch the other two as long as I have that pair of sides are parallel. So number 3, now we can say it's a trapezoid. And watch my wording here. Watch the wording. ABCD is a trapezoid because, ready? One pair of opposite sides. Can't say both pair because that's a parallelogram. One pair of opposite sides parallel. Okay, please don't write in both pair. You didn't show that. You only showed one pair of opposite sides are parallel. All right, questions there. All right, odds pretty slim. I'm going to ask for a trapezoid. Probably a lot more greater the odds. Me asking for the isosceles trapezoid. Prove isosceles. Same proof, extra step. Okay, same proof, extra step. So go ahead, throw down Nora. Oh yeah, that spells Nora. All right, so we have Nora. Now we got to prove it's an isosceles trapezoid. I'm going to start out the same way. I still need a pair of opposite sides parallel. Right, still need those. So slope formula for, and we can tell by the graph what two it's going to be. AR and NO, they have to be parallel. And I made this one easy on you because look at those. There is no rise over run. I can't count anything. They're just horizontal lines. Anybody remember that one? Horizontal line, slope of 0. Yep. Vertical is undefined, but horizontal, slope is 0. All right, same thing. Step 2. What do you know about AR and NO then? We just did the slope formulas. Tess, what do we know about those two now?
AR and NO.
There you go. AR parallel to NO because slopes are equal. Okay, it's just a trapezoid though. I need isosceles, so this is where the extra step comes in. Now I have to show you the non-parallel sides are going to be what? Congruent. And now I need what formula? Distance formula. All right, so there's the extra step to show it's isosceles. Now in step 3, distance, show me the distance formula for AN, and then show me the distance formula for RO. And we hope that they come out to be the same. So take your time here now. Gotta know your distance formula, right? I'm not gonna throw it up to the board at this point. All right, should have got distance 5. Square root of 25, which is 5. So each distance should have came out to be 5. Any issues on how to get that? All right, again, you got to get in this habit. Anytime you throw a formula down, the next step is, what did I learn from the formula? You didn't learn it was an isosceles trapezoid from the formula. What did you just learn from about AN and RO from the formula? AN and RO. Zoli?
Yeah, they're the same.
Which means they're what?
Congruent.
Okay, so AN congruent to RO. Because, how do we know they're congruent? I'm going to ask all these questions here. Stellan, how do we know they're congruent?
Because the distances are
Done.
congruent.
Yep, because distances are equal congruent. Anytime you throw a formula down, next step, what did you learn? Congruent, parallel, perpendicular. And now we can wrap this up and say, hey, Nora is an isosceles trapezoid. And let's watch the wording here now, right? Let's watch the wording here. Same wording as trapezoid with a little extra. Because one pair of opposite sides parallel, that would make it a trapezoid. And now let's make it into isosceles. And the other pair congruent, or the legs congruent, because we called them legs. Just making sure you clearly say one pair is parallel, the other pair is congruent. All right, I got some, any questions? Because you're going to, isosceles trapezoid probably is the one I would ask versus the trapezoid. All right, I need you to do some work in your groups, actually talk to each other. Your first job is to find the midpoints of the non-parallel sides up here. Find the midpoint of AN, find the midpoint of RO in part B, okay? I shouldn't be doing this at this point in the year, but I am. X1 plus X2 divided by 2, Y1 plus Y2 divided by 2. All right, so in your groups right now, make sure all you agree. Before I call on people, what's the midpoint of the legs? Find the midpoints of the non-parallel sides. And you're going to call one of them E, which is the midpoint of OR. And you're going to call one of them T, which is the midpoint of AN. Okay, so find your midpoints of those sides. Make sure everybody agrees. Okay, how about those midpoints now? How about those midpoints? Let's start with, I need the midpoint of side OR. The midpoint of leg OR, and we're going to call that E. You ready? Vinny, how about that midpoint of ROOR?
5, 4.5.
Good. 5, 4.5. If you guys haven't done so, you mind graphing that for me too? Point E, 5, 4.5. Thanks, Vinny. We're going to call that point E right there. Point E. And then somebody else, how about the midpoint of AN? Midpoint of AN now. Stephanie? Okay, that's fine. No problem. Jonathan?
Negative 1, 4.5.
-1, 4.5. If you guys wouldn't mind, please graph that as well. Point T. Okay, so everyone's got T and E on there. All right, ready? Because I'm going to be going back and forth between this page and the last page of your notes now. Connect TE for me. Connect them right now. Connect them and form a segment. That segment is a special one in a trapezoid, a special one. Let's put a name to it first. Remember, we just connected the midpoints. It's called a mid-segment. It is called a mid-segment, all right? Mid-segment. That is when you connect the midpoints of the non-parallel sides. Mid-segment. Okay, I have to connect the midpoints, though. They have to be midpoints that I connect. All right, there are two properties of a mid-segment I need you to know, and we're going to find them out together. First thing, real quick, how about the slope of that mid-segment? I don't think we have to do any rise over run, do we? ET, what's the slope of that mid-segment? Simon?
0.
0. Why? It's a horizontal line, right? So slope is 0. Whoa, whoa, whoa! Whoa! Weren't the two bases also have a slope of 0? So what do I know about all three? The two bases and the mid-segment, if they all came out to be the same slope. All three of them are? There you go. All right, all right. So go next page. Let's write down that property of a mid-segment. Woo! I like it. Property number 1, the mid-segment. It is parallel to the, oh, this would be great. Come on now, dig deep now, dig deep. What do I call those parallel sides on a trapezoid? Bases, yes. It is parallel to the bases. Good. One more property. Go back to our diagram on the previous page. No distance formula is needed. You just can count. I need you real quickly. Find the distance of the two bases and the mid-segment for me. Find the length of all three of them. Should be no distance formula needed. Yeah, yes, here we go. RA, base RA. What are we looking for there? Simon, again. 2, yeah. How about base ET? The mid-segment ET. What was the mid-segment length there? Mid-segment, 8, Char? 6. And then base NO. Stephanie? 10. All right, here's what I have for you, above average math students. If you know the two bases, what can I do to find the mid-segment length? If I know the length of the two bases, what can I do to figure out the mid-segment length? Go ahead, Zoli, what do you think?
So the distance between NO and RA is 8, and half of that no wait. half of that is 4, and then you subtract 4 from 10.
Okay, you got there. What do you get when you add our bases here? 12, and you take half of it? 6. That's how you get the mid-segment length. Add your bases and divide by 2. All right, so the length, property number 2, the length is equal to, excuse me, mid-segment length is equal to half the sum, meaning I'm going to add, of the bases. All right, half the sum of the bases. So add your 2 bases, take half of it, you got the length of the mid-segment. And here's how we'll end class. I will give you as much time as needed in your groups to work on problem number 3 to find x and y. But hey, little heads up. The trapezoid below is isosceles, so you got some properties you can work with. All right, you have some properties, and this segment here is the mid-segment. All right, so I will give you as much time as you need to work in your groups on how to find x and y. But keep in mind it's isosceles. All right, you got a couple properties working for you. Go ahead, talk it over in your group.
These 4 things are 4 lengths. What is that? Is there angle rule?
What is it? If we add 32 and 13 and divide it by 2, we take that and set it equal to a minus 1 and then divide it. And then y is just isosceles, so this is also 72 and they're same time period, so they're supplementary. It's easy. X goes to 32.
2 plus 5 on 2 is equal to divided by
45, 2x minus 5 is 25.
So 74.
X is 25. Is 13 is 45. Oh wait, no, we gotta divide by 2. Let's ignore that. I got 2. 13 equals 45.
No, they're not.
22.5.
This is for debate. This all things for these 2 are 76. And this plus it's just this plus 7 because this
So X is
those
X is 13.75.
No.
All right, guys, we gotta write something down here. Come on, we're not giving up here. It's isosceles, so you should know some properties from yesterday. We just went over the mid-segment, how to find that. let's get going so you guys can get going on the assignment. All right, I was trying to stress to you that this is isosceles because right now where the 72 is and the 5y minus 2, they have no relationship. Okay, right where I put them, those two angles have no relationship. I kept stressing it was isosceles because isosceles means, hey, base angles are congruent. So that allows me to put a 72 here. Now that 72 and 5y minus 2 have a relationship. A pair of opposite sides are parallel. And we talked yesterday, hey, these are called same side interior. They're not equal, they are supplementary. So that 72 and the 5y minus 2 are equal to 180. Okay, they're supplementary. So that gives you 5y equals 110. And y should have came out to be 22. Okay, y is 22. All right, moving on. Mid-segment. We just learned that a mid-segment, 2x minus 5, is equal to half the bases added up, 32 and 13. All right, you got a little decimal answer. It happens. What do we get here? 45, 22 and a half. So 2x equals 27 and a half. So our value of x should end up being 13.75. Yeah, it happens with a little decimal. Okay? Any questions on those two? Just a warning. When you do head over to the next question on the homework, it's just the trapezoid. I didn't put the word isosceles with it. So be careful on number 1. It's not isosceles, so the base angles are not equal on number 1. All right, so watch yourself there. Watch yourself on number 1 on the homework. It's just a trapezoid, not isosceles.